por tu invitación y por permitirnos este espacio a nosotros.
Claro que sí. Estamos todavía temprano para iniciar, faltan unos minuticos, estamos esperando que más gente se sume y yo creo que en unos 10 minuticos estamos iniciando, así que si te quieres quedar allí, ahorita empezamos, ¿vale?
Listo, perfecto. Yo me quedo por acá.
Buenos días. Buenos días.
Great. All right, hey everyone, welcome to the presentation. So today I'm going to be showing you guys our Viking hydraulic assistant. So that's our hydraulic calculation offering that's available both within Revit itself as well as standalone on the desktop application. In order to obtain the program, if you go to the main Viking website, which is vikinggroupbank.com, we do have a digital drop down here, Viking Tools for Revit. If you were to click on that, you're going to have that take you to the digital.vikingcorp.com. You can sign up and download. So for this hydraulic assistant program, we do require that you are an authorized user. So if you have applied for authorization and we've given you the okay there, so you would have got an email saying, hey, you got approved, you can just follow the steps in that email. If you haven't applied yet, you can go to the hydraulic assistant up top, request access now, fill out a short little form, and then you'll be approved shortly after that. The other thing that you can do on the main Viking website, we do have a training drop down here with a customer learning portal. This link will also be in your hey, you're approved email that you get from us, but this does have some courses and classes kind of around the program to help you get started. So with that said, I'm going to take us into the Revit world here and just, as I think Gabriel mentioned, start off about 30 minutes in the Revit world, show you how that works, and then take us out into the desktop program, and I'll pause in between for questions. So once you do install the program, it's one installer. It installs both the Revit version and the desktop version. If you're not familiar with our offering in Revit, we do have this Viking tab on the ribbon. This is part of the Viking Tools for Revit offering that we've had for a little bit. So this is where you can get the Revit families for the various manufactured product that Viking has. We have some applications to help you find the right product, and we do have some utilities to help with some connection items, some various things within Revit that can be kind of challenging or just time automation. The new offering is the Hydraulic Assistant tab. Once you open that up and you have access to it, it's going to look pretty bare until we get into a project. And then you're also going to get this docked panel here. So if you don't happen to see that docked panel, you just hit the home button. It should pop up somewhere and you can use it as you move forward. So for our presentation today, I just have a very simple system here. It's just a little tree system with a tiny underground loop and a little pump house outside, just as kind of an easy demonstration of how the software works. This does work on much larger models than this, but this is pretty easy to understand. So once you're ready to enter into a new calculation, you can hit the new project button in the dock panel. And then once you do that, you're going to notice that your ribbon up top gets a whole lot more options along it. So these are the various steps to performing the calculation. And then our dock panel here is going to change depending on what we're doing. So once you enter a new project, you're going to have the ability to provide just some basic context info, but more importantly, you can configure the calculation. So we offer both a demand and a supply type calculation. We offer both Hayes and Williams and Darcy Weisbach for the friction loss methodology. And then we do have some additional toggles and features in here that are pretty well covered within that customer learning portal section. Once you've gotten into a project, there's really three basic steps to running a calculation on a Revit model. So in the background here, I do have that simple model. And if I hover over one of these pipes here, hit the tab key a few times, you can see that everything is connected in the Revit environment. So our idea here is basically that the Viking tab, you're going to use this when you're laying out a system, when you're kind of designing it and placing things. When you're ready to run the calculations, you move over to the Hydraulic Assistant tab, and this is just pure play hydraulics. To run the calculations, there's only three steps really. The first step is to define where your supply is going to be within your Revit model. So if I move over here in the model, you'll see I've got a little water droplet looking item right here. this is our VHA supply family. So this just notes maybe where your city supply is or wherever you're going to be solving to. To define this within your calculation, you can just hit the Set Supply button up on the ribbon here. When I hit that, it's going to pop up a little dialog. This is just going to say, hey, you have two options here. You can hit the Insert Supply button. That's just going to load this family in and let you place it. Or you can go with the Select Supply route. So if I've already got that family loaded in, or if I want to use any other item as a supply, I just click that item, and then it puts me into a Revit mode where it's going to say, hey, please go select a supply. So at this point, I can go grab that pipe cap family, and this would be my supply location, or I can actually go grab any other mechanical equipment or pipe accessory in the model. So if you wanted to solve to somewhere on your riser, you can go pick a valve. If you want to pick one of these, fittings, you're welcome to do that. You don't actually have to use this supply family. We're pretty agnostic in terms of what you're allowed to do and how you're allowed to model the system. So once you have decided what item you'd like to use for your supply, you just click on it. You're going to get another little dialog pop up asking you to define some supply information. So since I had already seen this supply, I've already got some information associated with it. Otherwise, you can just key in whatever information you need here. So the first item is the supply name. So this is just a contextual name that you can provide for the supply. The next is the name of the node. So this is how it's going to be represented in your NFPA printouts, your pipe tables, and your hydraulic results. Below that, you can provide your hose allowance if required, static pressure, residual pressure, and residual flow for that supply characteristics. So this would be your city supply curve generally. Once you're satisfied with the values you see here, you just click the Done button, and then that's the first step for running a calculation. The second step, I'm going to move us into a floor plan view and move us over to our remote area over here. So our second step here is to create a design area. I've got a filled region drawn in the background here, just notating roughly what my remote area is going to be here. So it's about 1,500 square feet. So it doesn't have to be, exact, but you can tweak this however you need to, just with the normal Revit capabilities. Once you're ready to define your design area, you just click the Design Area button up on the ribbon. It's going to pop up another dialog here where you can provide some basic information about the system. So you can provide a name for the design area. So this is just whatever you want to call it, just a textual name. Below that, you can define some characteristics about what the minimum flow for that system is going to be. So here, there's a few different inputs, but you're able to mix and match what you're looking to accomplish here. So for instance, if this was a ESFR type system, I might only provide a minimum pressure and I might leave the other values blank. Since this is a density area system, I might provide both a minimum pressure as well as a density and an area per sprinkler head. To pick the heads that I want to flow in the model, we have two different options. We can leverage a filled region, as I have in the background here, and you can use the Draw Area button to go draw that. Or you can pick the Select Sprinklers option, which will allow you to actually go pick specific sprinkler heads in the model that you want to flow. So both options work pretty well. Select Sprinklers is obviously a little more tedious, but more specific. So for this demo, we're going to use the Pick Filled Region option. And then this is just going to put us into a mode to go grab a filled region out in the model. So if I select my filled region here, I'm going to get a little pop-up, and it's going to have all of the sprinkler nodes that we found within that filled region. And we were able to pull out, you can see 13 different sprinkler heads here. So what this pop-up is essentially the flowing sprinkler heads within our pipe network and our Revit model. So working left to right, you do have the option to actually add or remove rows here. Anywhere you see this locate icon, this allows you to actually go check out what item that's associated with. So here we provide a default naming here, S1, 2, 3, etc. So we have a default prefix of S, and it's just a numeric increment there. If you're curious what that item is, you can hit the locate button. It will zoom you to that item in the Revit model. It will set it as your currently selected item, and you can get some idea about which item that is. So S13, if I click on that, it's going to be the sprinkler head down here. After that, anywhere you see these darker black text items, these are all editable fields that have been filled in for you. So the K factor here, this is going to get read out of the sprinkler family. So if I check that sprinkler family in the background, scroll down, you can see it does have a K factor field set to K 5.6, so you didn't have to type that in. We'll read it out of the model. After that, you have your density and area, minimum pressure that you all provided, the calculated minimum flow. So this is going to decide if the density area or the K factor pressure are more demanding. And then on the right-hand side, we do have some results once we get the calculation running. So once you have extracted this information, as mentioned, you can click into any of these darker fields here and actually edit them. So if I wanted to change the K factor here to K8, I can change that value, click out, and it's going to ask if I would like to change every single row or just that single row. So when I click yes here, we'll see all of the K factors update to K8, and you might notice that the minimum flow gets recalculated as well. So here, just to bake it down, you're extracting from Revit which sprinkler head you would like to flow, and you have the option of tweaking that information once it comes out. And then I can change it back to K56. So that's the second step. So we set our supply, we chose some heads that we would like to flow, and then our final step here is to extract our Revit pipe network out of the model. So I showed it early on, but there is a little trick within Revit to check the connectivity of the model, and that's by hovering over a pipe, hitting the tab key a few times, and that'll tell you what's connected. Works very well on a simple model like this, but in a much larger model, it can be a little bit convoluted and problematic. So we do have a reachable pipes utility here, and this will help you check and figure out what's reachable from the source and what we're going to be able to pull out and run the calculations on. So this is relatively straightforward. We do have a big blob of text here just explaining what it is, but you can assign a color to the reachable and unreachable pipes. And all you do is you say color the reachable pipes. You'll see everything that's findable get colored in blue here. And then you can use that to kind of do a little double check for yourself on what is or isn't accessible from the calculations perspective. Okay, let me bring the pop-up back up. So you can pull those colors out with remove reachable colors. Sorry, I had to mute someone. And then it'll go back to the uncolored state. So to give you an idea of what that will look like if not everything was reachable, I'll go to my Modify tab within Revit, use the split pipe command, and I'll just break this pipe over here to cut off a couple of these branch lines. Cancel out of that command, go back to my reachable pipes utility, color the reachable pipes, and you can see here that these branch lines are no longer colored in blue, and they wouldn't be able to be represented in the calculation program. You can couple this with color unreachable pipes to get a really clear view of what is or isn't reachable from the calculations perspective. And again, you can pull all those colors out as needed. So that's just a little pre-process that you might want to do to figure out if your model is correctly connected and everything you'd expect to be accounted for is. So once you're ready to pull the pipe network out, all you have to do is hit this trace pipe button up on the Revit ribbon. Once you do that, you're going to get a little pop-up here, which is all of the unique Revit items that we found within that pipe network. So I haven't talked about it yet, but we're very agnostic about what you actually draw within your Revit model. So if you look in the background here, this is essentially just a generic fitting that you might have found in a stock Revit mechanical template. This pump family here was just one that we grabbed off the internet. And the way that we do that is through this mapping phase right here. So what we present you with is a list of all of the unique Revit families that we found within your pipe network. We give you that list in these first three columns with some information, and then we ask you in this final column over here to map them to something in our component database. So that's where all of our internal diameters and equivalent lengths and other items live. So if I were to click on this first pipe here, you'll notice it's a pipe and it's called FP Underground. If I were to look at my little table here, you'll notice that I have a pipe called FP Underground, and it's just classified as a pipe. So this final column over here is where you can map that item to something with known properties. Once you've mapped an item, we will keep a record of that, everything's already filled in for me. If I happen to be working in an alternative standard, like FM3-0, you'll see that some of these cells are blank here, and it would be on me to come in, click in, and then map that item to whatever it might be. So this might just be a T. This item right here might be a 45 elbow, could be a 90 straight flange, could be a screwed elbow. It's on you to come in, map those items appropriately, and then once you have everything mapped, as I do in my NFPA 13 approach, I'll treat that as cement line ductile iron, you just hit the build pipe table button, and then at that point, our calculations are running, and all of the information we need to perform that calculation has been filled in for you. So once you do have some results running, you'll notice that the dock panel has gone to our supply stage. So we have all of our city supply details. We have our numerical results here. And then we have our status message saying, hey, the calculation finished successfully. Took this many iterations, this much time. So anytime we're attempting to run a calc or are running a calc, this message here will be updating, giving you some context of if it's running or not and why it might not be running. Once we do have some results, if we were to go back into the View Design Areas button, you're going to notice that our flows are filled in and our pressures are filled in. So anywhere you see a table or a tabular structure like this, you can actually click on the headers and sort. So if I wanted to see the most demanding sprinkler, I can sort by pressure ascending. I can see it's this S13 item. Click the locate button, it'll zoom me to that item. And if I zoom out a tiny bit, you'll see, that's the most remote head on the most remote branch line. So it makes a lot of sense that that's going to be the most demanding one. Another thing you can do is click on the results button, and that's just going to pop up your numerical results on the left-hand side here, as well as a nice little graph for you. So your solid green line is going to be your city supply. Your solid blue line is going to be your system demand. I did have a pump on this system, so you can see I have a 500 gallon per minute, 100 PSI pump. So this dashed green line is my pump curve, and then I do have a combined curve above that. So to explain a little bit about what's happening when we're doing all those steps there, I'm going to click the Open UI button. And what this is going to do is pop up the full Hydraulic Assistant user interface. So this is actually identical to what you would see if you were within the desktop version of the program. So if I just maximize this, you can see that we've got it broken up into a few different tabs along the top here. So the first tab is the project tab. So if you recall, when we made a new project within Revit, the doc panel said, hey, what's the project name? What calculation method are you using? What calculation type? So we were essentially filling in this project tab here, and you can always come back at any time and swap those items. So if you wanted to see what this looked like from a supply perspective, you can just swap that over. And then if I were to look at my supply graph here, you can see that would fit somewhere along the combined curve. So again, pretty straightforward, pretty quick calculations, and you can swap those items at any time, go back to a demand perspective. So in Revit, when we hit set supply, if I move over to our supply tab, all we were really doing is filling in this information up along the top, telling us, hey, these are the characteristics of my supply, and this is the node and location. When we pulled the design areas out, we're just filling in the design areas tab. So this again should look exactly like what we're looking at in that pop-up when we extracted these nodes out of Revit. And then finally, when we did that trace pipe, we're going to be filling in our pipe sections tab here. So this is the kind of heaviest lift of the process. So this is where we're pulling all of the pipe sections out of your Revit model and then building this hydraulic table for you. So kind of working left to right to explain the table, it should be pretty similar to like a Haas or HydroCalc if you've ever seen one of those. But essentially you have the option of manually adding and deleting rows. We do have our little locate pipe button. So if you wanted to match up this table here with the model, you can say, hey, I have a pump here, show me the pump. And then in the background, it's going to zoom you to that pipe section. If I scroll down a little bit, you'll see I have a butterfly valve and an alarm check valve. So if I wanted to find that pipe section, I just click that show me button and it will zoom me to it and show me kind of where it is in the model. After that, we do have the ending and starting nodes. So you can see for the non-sprinkler items, we have a default prefix of N. You can actually come in after the fact and update these to whatever you'd like. So if you'd like to break out your underground pipes and call them, UG 1, 2, 3, 4, 5, you can just come in, click, and then update those node names there. And you can see that once you change it once, it's going to update all other references of that item. So again, you can just come in, customize all this naming however you require, and then go from there. You have the pipe schedule. So back in the Revit world, when we used the mapping, we said, hey, treat all that FP underground pipe as cement line ductile iron. It's going to pull the diameter out of the Revit model, the pipe length, your elevations, and then it's going to assign all of your fittings for you. On the far right, in the kind of grayed out text, we have all of our results. So you have things like your flow through each section, pressure loss due to friction, pressure loss due to elevation, starting and ending pressures, velocities, and so on. So that's just kind of explaining, hey, you do these 3 steps in Revit, and you're really filling in this big form in the background, and you do have some flexibility here to update what's pulled out of the model. We do also have a simplified sections tab here. So back on the pipe sections tab, we had a row for every single pipe in the model. That can be pretty busy, pretty heavy. The simplified sections is a lot closer to the NFPA 13 simplification that you might see. And it's a lot easier to interpret as it breaks down all the similar pipe sections into a single row here. So you can see instead of a couple hundred rows, we only have 22, and it's a lot easier to interpret the results. So you can sort by the friction loss, see what, is there any pipe diameters you're having specific issues with, or velocities and so forth. In addition to that, we do also have a fixed flow PRV tab. So if you need to add a fixed flow for something like a standpipe calculation, you can do that here. We also have a node summary tab. So again, just the node names, elevations, if they're a sprinkler or not. And then we do have a bulk edit tab that you can use as well. Once you're in kind of the post-calculation stage in the Revit world, we've got a couple of different items you can do. So you can hit the Create Submittal button up top. That's going to pop up another dialog for you, which has a few tabs along the top. So on this dialog here, you can fill in essentially your NFPA 13 cover sheet. So you can choose what you do or don't want to fill in here. So maybe this is my office. It's going to be a light hazard occupancy, fill in my density, area, coverage per sprinkler, and so forth. Once you're satisfied and you're ready to actually print this out, we do have some options under the print options regarding what you'd like to include. So if you don't want to include these 3 information items because we didn't fill them in, you can just uncheck them. For me, I'll just check all the other items in here, click the print button, and then once this is done, it's going to open up in your default web browser our results file here. You can just print it out to a PDF from here. But essentially, kind of top down here, you get your calculation summary sheet with some information that you did or didn't fill in there. So this is that details that we filled in on that table right before this. You'll also get some result-based information, such as the total system volume. If it's a dry system, we'll break out the dry volume if you want to size a compressor or something. Below that, you do have your graphical results. You get your numerical results, so this is going to be exactly what you're looking at in the supply tab. You get a summary of all the nodes in the project. So this is going to be all your sprinklers, all the other important nodes, what their elevations were, K factors, what their pressure was, what their outflow was if they're a sprinkler head. Below that, you're going to get your NFPA 13 printout and pathing. So here we're going to have a path 0, and then as many paths as it takes to represent all sprinkler heads. So this is just going to start at our most remote head, S13, and then it's going to work its way out through all the connected pipe sections. You can see our renamed underground nodes here, all the way out to our supply node. Beyond that, you're going to get however many other paths it takes to represent every other flowing head. So we have a couple other branch lines, so we get a path 1 and a path 2 here. Then below that, you can opt to include that simplified pipe table. So this might be nice for representing things like transfer lines in a gridded pipe system. And then I did opt to include the EQL basis. So, here it says, hey, there's 2 T's on this pipe section. I can then go reference this table, find the T's, find the base equivalent length, and then kind of match it up just to double check for yourself. If we happen to have any flex pipes, that would be present here. I did have a fire pump, so that's got a curve to it, and these are the coordinates that were used to build that pipe curve. And then finally, you can have a full pipe table here at the bottom. This is probably overkill for most situations, but it does include information like the internal diameter, the C factor, roughness coefficient, and everything for every single pipe within the model. Once you're satisfied with the calc, you can also leverage some tagging. So if I were to lock my 3D view here, just call it 3D, we do have a tag nodes function. So within here, we've got a few different options about how you'd like to tag your model up. So if you just wanted to tag the flowing sprinklers in the model, you just say, hey, tag the flowing sprinklers. And then you're going to see over here, we get some tags that pop in around our remote area. If you want to add to that, you could say, oh, I would actually like to tag all the flowing nodes. And you'll see we'll get some tags kind of running our way down that main over there, out through the riser, out through our pump, and then out to our supply. All these tags are view and design area specific. So if I were to go to my floor plan view here, you'll see there's no tags present. I can come in, tag nodes. Maybe I just want to tag all the sprinklers here. I can run that command, and you'll see I'll get tags popping in around all of the sprinklers. This is a nice little double check about, remember when I disconnected these branch lines here and it said, hey, these aren't reachable from the calculation. Well, you can really see that in action here, where we're telling you, hey, the calculation doesn't know about these sprinklers over here, and that's why they're not tagged. And then finally, we do have a hydraulic placard option that you can utilize to create a little Revit schedule or like a little table that you can include with your drawings. So that's the real quick run through of the Revit world. Gabriel, I don't know if you want to see if there's any questions at this point or anything like that. All right, I'm going to assume no questions then. Or if you do, I guess you can type them in the chat. All right, so we'll kind of move on to the desktop version of the program now then. So everything that you're doing within the Revit model and the Revit world is totally applicable to the desktop version, because as mentioned, when I open this user interface, it's really the same program. So to accompany that, we do have a little extract geometry utility, and this has the ability to pull out some basic information about your Revit model, such as walls, ceilings, and floors, and bring that along with the calculation file. So if I just run that command, open up the UI, I can say File, Save As, save this file as temp.bdb. I'll overwrite my existing one. And then at this point, I can leave the Revit environment and then go out to the desktop version. So when you run the installer, it's going to install the add-in for Revit 2019 through 2024, and then it's also going to present you with an option to create a desktop shortcut, which is what I've got here. This will also be present in your start menu under the Viking folder. It's just called the Hydraulic Assistant. So when you're ready to go into the desktop version, all you've got to do is double click the shortcut. It'll open up the desktop version of the program. So in the desktop version, you've got a slightly different looking splash page here because we've got a bit more room to leverage. So here you can create a new project, open an existing one. We do have some news from Viking. If you need some help, you can contact us. So I'm just going to open up that same temp.vdb file we were just working in. And then at this point, I'm totally outside the Revit environment. I can go over to my pipe sections tab. You can see it's all the same information that we're looking at in Revit. And you can kind of go from there. So you can absolutely hand off your Revit files to someone who's only working in the desktop or kind of open them after the fact without any issues. Something I didn't touch on in the Revit world is the 3D viewer. So this is available there, but it's a little bit more performant than the desktop version. But if you open that up, you have the ability to view a little 3D representation of your pipe network, as well as some of the results. So if I kind of zoom in over here on my remote area, you can see that you can observe the pressures and flows out of things like the sprinkler heads, the flows and velocities in each pipe, and a lot of other information. Did you have a question? You can feel free to ask it. See you raising your hand.
Hi, good morning.
Hey, good morning.
Brendan, I have a question.
Sure.
This tool does it works with other Revit families. If I understand, I have to add the counterpart in the tool.
Yeah. So if I kind of go back to the Revit world, when we trace that pipe network out, we presented you with this mapping dialog. So we're very agnostic about what Revit families you actually utilize. So you can draw with anything. You're going to get presented with this list of all of those families, and then we're going to ask you to map them to something with a known hydraulic property in this final column here. So this is where we're saying, hey, treat this pipe as cement line ductile iron. You could say treat it as blue grout. Here's a model J1 alarm check valve from Viking. This is where you can map that to, maybe it's a DXR valve, maybe it's our DXD valve or something like that. This is all driven by what we call our component database, and you can access this through the component manager button. So if I kind of maximize this and just walk you through it a little bit, this is where all the hydraulic properties for the things you use in both the desktop and the Revit version live. So we've got a few different types of components that you might encounter here. One of them is a curve type component. So this is pretty commonly encountered on things like a backflow preventer. So every time you go into our component database, we've got kind of a category, subcategory, and then a component. Once you click onto a component, you've got a details tab, which is just some basic generic information about it, such as the name, if you wanted some description and whatnot. The second tab is always going to be the hydraulic properties. So if you're familiar with a backflow preventer, generally the manufacturer puts out a loss curve of some kind. So here, if I click on the 4-inch nominal diameter, you'll see we have some X and Y coordinates that lead to the following loss curve. So you can build this off of their tech data. If I click onto the 6-inch, you'll see there's a slightly different curve there, and so on. This is also where things like fittings live. So if I go to our NFPA 13 category, click onto the elbow, you'll see I've got just a generic elbow, but under the second tab, I have our diameters and our equivalent length in feet. Anywhere you see the owner set to V or Viking here, that means that it's something we've distributed in our stock component offering. So those items you are not allowed to edit, but you are allowed to come in, add your own component. So this could be your custom elbow. Click OK. And then when you do that, the owner is going to be you, and you can come in and control the information. So if you wanted to add your own elbow, you can just come in and provide whatever information you need here for the equivalent lengths. Other types of components, we've got things like flex pipes. I'm going to jump down to the pipes here. So if I go into the Schedule 40 pipe, we have, this is where your C factor and roughness coefficient live. Under the second tab, we've got some internal diameter information. Did you have a question, Jose? You can feel free to key up and ask as well.
Yes, sir.
Yeah, thank you very much.
Yeah, and then we do have pumps as well. So those would just have a pump curve. So did you have a question, Jose?
Yes, sir. I have 3 questions. I hope you could understand me. First of all, are you going to release a version of this plugin for AutoCAD? AutoCAD?
No, we are not planning on supporting AutoCAD.
Okay, very well. I have been working with this tool only in the standalone version. Okay, I haven't used it in the Revit version because I don't know how to use Revit. Okay, and I found 2 issues that appear to be real. The first one is that you have to put first the last node, the end node, before the start node. Okay, I wonder why. Regular hydraulic calculation software used to input first the beginning nodes and after that the ending nodes. Okay.
You can actually go in either way. So by default, it's end to start, right? Which is, I think, what you're asking about. If you want to order it the other way, there's this sprinkler to source toggle here. If you toggle that off, it goes start to end. So if you're more comfortable with working in that direction, you can just toggle that.
Too simple.
Yeah, and under the configuration tab, just click configuration, go to program. You can actually default that. So if you always want it to go start to end, you can just toggle that here, and then every new project it'll use that setting.
Okay, understood. Okay, and the second one is that I tried to make a standpipe design using the software, but I couldn't find a way because there is no way. Well, I didn't find it. There is no way to establish that you will not use a density area.
Oh, okay. Yeah, I can show that real quick. It kind of plays into the desktop version anyways. Yeah, so if you want to do a standpipe calc, and for those, I actually also like to work my way, kind of start out. So here, let me just start a new project, turn that off. So if you want to manually build out a pipe network in the standalone, you basically got to build a big table here that you can work your way through. So same ideas within the Revit model. You know, you can provide the name of the start node, the end node, come along, pick a pipe schedule, pick a pipe diameter, so maybe it's 4 inches, 10 feet long, give it some elevations, maybe it's got an elbow on it or something. You can come in and you can hand key this information in. So you're asking about a standpipe calc. I'll do a real simple one here for us, and I'll tie this into the design 3D option. So you can just come in and, create a bunch of pipe sections here by hand. If you've got a simple item, you can open up the 3D viewer. It's going to give you, our one pipe section here. So if we want to just create a very simple standpipe, we'll say, and I didn't really cover this, but you can click on items within the 3D viewer. So when I click on a pipe, it gets highlighted in yellow. Its details get filled in here. So if I want to change the length, I can change it down to 5 feet, change it up to 10 feet, and so forth. If you want to create a new pipe in the viewer, you can click on a node, it gets highlighted in yellow. You can choose what you want to create, hit that create button, and it's going to start creating the pipe nodes for you.
Yes, I did that.
So, Yep, so up here, I'll just change the top node to SP1, standpipe 1. I'll close out of the viewer here, go to my supply section. So here I just need to tell us what node is going to be, where my water's coming out of. So I'll just set that to SRC. I'll provide a static pressure, residual pressure, and residual flow. So now I've got my supply defined, I got my pipes defined. You're most likely going to the design area tab and trying to fill in a sprinkler here. If you're looking to do a standpipe calc, you go to the fixed flow PRV tab, add a fixed flow. It's going to say, hey, you're going to need at least one design area. We can make one for you. So just click yes. And then you just say, okay, at SP1, I want to flow 250 GPM with a minimum pressure of 65 PSI. And now if I go back to my pipe sections tab, you can see our flows filled in with 250 gallons per minute. We have our friction losses, elevation losses, and our pressure working our way back. And then if I go back to the 3D viewer, you can see the pressure is 65 PSI at SP1 working its way back to the source. So does that kind of get you where you need?
Yes. Okay. So it doesn't need to be a density area, a design area.
Correct.
Okay. Okay. And the last question, last but not least, where is it when you are using the pipe section input data section, the pipe section input? Okay, there are two options. Copy. Can you go there to the pipe section?
Yeah.
Okay, there are two options. Copy and on the left, okay. A copy and I don't remember the other option. What is the difference between the two ones? There's copy row and duplicate row. What is the difference? Because I saw that depending of the selection, okay, the node could change the names by themselves, and I got confused when I did it.
Yeah, understandable. So the difference between them, if I just do a little new project here, insert pipe section, So if you happen to have just like a similar pipe section, maybe I've got an arm over here, and I'll just fill it in with some basic info. 1 inch, 3 feet, 19 feet, 20 feet. Got like a T, couple elbows. So the difference here is that when you click the middle button, which is duplicate row, it'll carry over all the same information as that row, but it's going to not assign any node naming. So if you have a bunch of typical sections, like a bunch of arm overs, like S2 to N2, S3 to N3, this is a very straightforward way of keeping all the elevations, the lengths, the fittings, the components. If you want to go with the other method, it's really designed around kind of working your way back along a branch line. So if we had like, S1 to S2, schedule 40 pipe, 1.5 inch, and it's like 10 feet long. I can type 10 feet, 20 feet, 20 feet. If you click this leftmost one, you'll see it kind of carries on the naming. So it fills in the next node here with the last one, and then it populates a new node name for you. So it would be S2 to S3, S4, or however you want to name it out. But what it's doing is it's copying information over and kind of filling it in a little bit for you. So, if you're working your way back a branch line, it might save you some time. Otherwise, it might be wasting some of your time. So it's very pick exactly what you're looking to do. Does that kind of make sense for you, or?
Okay, yes, I understand. Thank you, sir. You have been so kind.
Yeah, no problem. Cool. So in that, quick question and answer session, we kind of covered a bit of what you can do on the standalone. Obviously, you can hand key in stuff. You can go into that 3D viewer and, modify things, draw a new pipe in there. So obviously, you have the ability to run hand calcs in the program. Something else that we offer, if I make another new project here, is this other tab, or this other icon up here on the ribbon, which is our ability to kind of generate a starting point for you. So if I click that, open it up, it's called the pipe generator. So what this allows you to do, if you notice in the background, I don't have any pipe sections right now. This lets us generate you a starting point for just a typical tree, grid, or loop type system. So when you come into this program, you work your way left to right, the first option is the type of layout. So if you have a tree type system, we're giving you a little preview of a tree. If you wanted a grid type system, you'll preview of a grid, and same idea with a loop. So you pick the type of system you'd like to lay out, and then you kind of work your way through the inputs. So here we have our SRC to BOR, so that's going to be our underground. If I want to make that longer, I can just change that to 25 feet, change the elevation. Maybe that's going to be a blue brute pipe. You can control the riser. And then once you get over to the mains and the branch lines, you're going to see that the elevation starts, mattering a little bit more here. So when our main's at 19 feet and our branch is at 20, you'll see we get a riser nipple automatically for you. And so we've got kind of a naming scheme going here. TLR is the top of the riser, RN is a riser nipple, BL is a branch line. So if they're both, at 20 feet, you wouldn't end up with that riser nipple. You would just have it cross there. You get a similar interaction with the sprinklers. So they're either right on the branch line, or if they're above or below it. So maybe if they're at 19 feet, you'll get a sprinkler drop there, and we'll add some fittings in for you as well. So all these diameters and pipe, schedules are all controllable individually. So if, I wanted to change those sprinkler drops up to a foot diameter, just to give you an idea of what it looks like, hey, I'm specifically changing this one type of pipe within the model. The other thing that you can do in these center columns over here, if you're in the tree type system, you could change this to a side feed. So instead of just having a centered main there, you can put all the sprinklers on one side of it. And there's even some tweaking beyond that. So if I wanted 2 heads on one side, the rest on the other, I can use this fine tuning input to accomplish that. The final little section here, do you have another question, Jose? Or?
Yes, sir. May I export the file from the standalone version and then import it from the Revit, obtaining a Revit model?
No, we can't currently create a Revit model off of the standalone version.
Okay.
So, yeah, we can't go automatically create that pipe network for you at the moment. Yeah, and then for the final kind of set of inputs here is where you're controlling the overall size and shape of the system. So if you're controlling your branch line spacing, you can bump that out to 14 feet. Maybe you've got 15 branch lines. Maybe it's 14 between each head, 20 heads per branch line. You see, you can pretty quickly array out a relatively large system here. The other option is that you can choose just however many branch lines you need. So I need 3 branch lines here. I could just create a very simplified pipe sections and then go extend out this one pipe section here later if I needed to. But for us, we'll just keep a relative amount of branch lines. Once you're satisfied with the overall layout and shape of the system, you can go over to the sloping tab. So if you wanted to apply some sloping here, you do have the option of doing so. We do have a sizing tab. So by default, we have a uniform size along the branch lines. They're all 2 inches here based off of what I picked back on the layout tab. If you want to apply something like an NFPA 13 pipe schedule method, you can change this to telescoping, at which point you can define, hey, I want 1 head on 1 inch pipe, 3 heads on 1 inch and a quarter. And as we work our way back up the branch line here, it's going to start sizing up the pipe as we get closer to the main. The final inputs here is under the design area tab. So we'll generate an initial density area design area for you. So if you notice, some of these nodes here are labeled as sprinklers and they're colored in red. Those are our theoretical remote area for these inputs. So if I were to bump this coverage area up to 3,000 square feet, you'll see we'll get a few different sprinkler heads pop in here based off of the NFPA requirements for how many heads per branch line. So yeah, you can come in, decide, okay, I need 1,500 square feet, 2,000 square feet, the following density, the following area, maybe it's a 0.15 density, choose the K factor, minimum pressure, and then once you're satisfied with this preview, again, we don't have any pipe sections at this point. You just hit that create pipe table, and then when this green bar here reaches the end, we're going to have created all of your pipe sections for you and kind of giving you a starting point. So see in the background, all my pipe sections got filled in. There's a couple hundred of them. Fills in all your elevations and pipe lengths and pipe schedules and diameters. It adds some fittings for you, add things like the riser nipples. I'll go all the way up to the top of the table here. You'll see it would give you an initial riser with a butterfly valve and an alarm check valve. So again, we're just giving you a starting point. Everything that came out of that, you can modify and edit to your heart's desire. So if you want to get rid of the alarm check valve, maybe add a dry valve, you can go ahead and do that. Very straightforward. If we go over to our supply tab, you can see that, for this kind of random situation, we've got not quite enough, city water supply availability. So you've got a few options there for revising the calcs. You can obviously go back to the pipe sections tab. On here, you can come change things one by one. So you can size the riser up to 6 inches. You can kind of go from there and change things on a singular basis. You could also go back into the pipe generator. So if I open this up, it's going to have all of the same inputs that I previously had. But if I were to regenerate this pipe network, I'll lose any changes I made. So this VXR valve is going to swap back to a Model J 1 alarm check valve. So this is where this bulk edit tab can come in. So if I go to my simplified sections, sort by friction loss descending, this can give you an idea of maybe where you're losing a lot of friction within the system. So, some of our 1.5 inch sections are losing 14 psi. Our 3 inch mains are losing 10 inches or 10 psi. So under the bulk edit tab, instead of changing things one by one, we give you, a quantity and a kind of grouping of all the various items, and you can update them all at once. So if we wanted to change all of our mains up to 4 inch, change all those, change these other ones up, and then now all those mains are no longer 3 inches, they're now 4, and we're losing a lot less pressure through them. Something else you can do is couple the 3D viewer with whatever kind of contextual changes you're trying to make here. So if I kind of zoom in over here, you can see that we have some results shown along this, this system here. I showed it when we were looking at the standpipe. You can click on the pipes, you can change diameters, and you'll get kind of an updated calc. So if I were to drop this down to a foot, we'll see that some of the calculation results change. Put it back up to the 14 feet and get the updated calc. So it's pretty interactive in terms of observing changes. Something we didn't cover was the graphics tab in this viewer. So this is where you can control a lot of information about what you are or are not viewing. So if you don't care about the pressures, you can turn that information off. You can turn the flow off, turn the diameter on. Then you have the option of saying, okay, I'm seeing velocities and diameters here. So again, pretty interactive for you. Another thing that you can use is some of the pipe coloring methodologies that are available. So by default, it just has some kind of error checking for you based off of, okay, you said it was a 10-foot elevation change, the pipe's only a foot long. We might color that in red. But you can also choose another method such as velocity. So here you can assign a threshold. For us, by default, it's 20 feet per second. And then any pipe that's violating said threshold is going to be highlighted in red for us. So that's going to be a prime target for us to go and size up to try to get our pressure losses down. So again, you can click in and one by one size them up. So if I were to size that one up to 1.5 inches, you'll see it drops it to 15 feet per second. Size this next one up to 1.5 inches, and that drops those down. So you can go one by one there. You can also use the multi-edit mode up top. So if I click into multi-edit, I can just drag a little window, grab these 4 pipes right here. Say change these all to 2 inches, click the set button, and then my calcs will be updated with those new results. So at that point, you can iterate until you get a working calc, or maybe you will have to add a pump. The final thing I'll show here is that you could create a design area. I'm not going to go into that, but it is an option. And you can also take some screenshots out of the 3D viewer here. So if I wanted to take a picture of my remote area, take a screenshot, call this my remote area, click OK. And then I could also go out over to my riser here. You could change the graphic settings. Maybe you do want to see the pressures. Take another screenshot. Call this my riser. Click OK. And then now, once I leave the viewer, if I go to my submittal printout, you'll see I've got a couple pictures here that I can include. Click the print button. And then now when I scroll down, you'll see we got a couple kind of pictures of the isometrics there included for you. So you can try to convey some context with what you're doing. So yeah, we've got a couple minutes left. Were there any questions, anything I didn't cover? I mean, obviously this is a real quick, real high level breeze through it. I do encourage you to check out that customer learning portal and the tutorial videos we send in the email when you do get access. But yeah, so any kind of closing questions or anything I didn't cover you expected to see or anything like that? Oh, I didn't mention it, but if I click configuration, go to new project, you can change to metric. So if you're more comfortable working in metric, you can actually change it anytime to metric. And then if you go to the pipe sections tab, all my diameters will be in millimeters and pipe lengths in meters and so on. Yeah, so I think I saw a hand. Did you have a question?
No, you resolved the question.
Was that it?
With that.
Yeah, so, yep, that toggles it over to metric. Everything's going to be in, meters, bar, liter per minute. Yeah, do you have a question? Yeah. Yeah, feel free to speak up.
Hi, my question is how to indicate the sprinkler pendant or upright?
You don't have to specify that. You just have to specify the K factor. Same with the sidewall. There's no delineation. And same with the dry sprinkler. If you weren't aware, the K factor for the dry sprinkler heads, regardless of the barrel length, is actually calculated at the connection point. So, yeah, it's just a K factor situation for you.
Any more questions? ¿Más preguntas? Ángel, ¿tiene una pregunta?
Yes. Hi, Brendan. Just a quick question. The resulting format is approved by NFPA. Is there no problem with the insurance companies in project reviews?
We haven't seen any real issues. If you happen to submit one and someone has a real issue, feel free to reach out to us and we can work with you on that. But yeah, we provide all the information NFPA would expect or ask to see. So we haven't heard any feedback that people don't like it, but if there is, feel free to contact us. So under this little help dialogue, you can go contact Digital Solutions and that'll come to us and we can work with you on whatever you need.
Okay. Okay. Thank you.
Yeah, no problem.
More questions? ¿Más preguntas? A los que no hayan diligenciado el formato en el chat de asistencia, les agradezco que lo puedan diligenciar. Ahí está el link. Les va a tomar 30 segundos nada más.
Mira, yo sí tengo una pregunta, pero para ti, no por el expositor.
Claro.
Buenas tardes, buenos días a todos, ¿cómo están? Excelente presentación del señor Brendan. Me aclaró muchísimas dudas. Toca jugar con el software y aprenderlo a usar mejor. Pero una pregunta, tú sabes que yo hice un tutorial de lo poco que aprendí a usar del software, pues lo usé en forma empírica, pues lo aprendí a usar en forma empírica. Y mucha gente me pregunta que cómo pueden acceder al software. Y tú me dijiste que solamente está restringido para ciertas empresas y ciertas diseñadores. ¿Cuándo tienen ustedes pensado liberar una versión del software standalone para el público en general?
Lo estamos liberando, no te preocupes. O sea, lo importante, incluso acá nos está mostrando Brendan cómo es el acceso. Para los que no hayan visto el acceso, ustedes solicitan, digamos, el acceso a través de la página. Pueden colocar nuestros nombres de la persona con la que tienen contacto, ya sea Gabriel Sánchez, Alejandro García o Armando González en el caso de México, y nosotros podemos aprobar esa parte, ¿cierto? Entonces,
Okay.
Lo importante es que puedan utilizar la herramienta, que puedan solucionar sus temas y obviamente especificar los productos Viking nuestros en los diferentes proyectos.
Sí, claro, eso es fácil de hacer.
Así es, esa es la idea. Así que por eso no hay rollo.
Bueno, muchísimas gracias por tus aclaratorias.
Perfecto. ¿Alguna pregunta adicional para Brendan? Bueno, parece que está. Brendan, I think that we are done. If we have any more